All right, so section 5.3 is on dividing polynomials. So last time we learned how to multiply, so we distributed in. If we had, a polynomial times a polynomial, we took every term from the first polynomial and multiplied by every term of the second. Was that okay on your homework? Did you guys get that?
Yeah.
Yeah, sometimes they take a while, but they're pretty straightforward. All right, so we're going to learn how to divide. So we talked about how to divide just a monomial by another monomial in section 5.1. So those were the crazy ones where you had like 10x squared y cubed over 5x to the negative 4 y to the fifth. So we already learned something like that. So monomials divided by monomials. Okay, so now we're going to learn how to divide by polynomials, so multiple terms. Okay, so this first one, I have a polynomial divided by a monomial. So when that happens, what you can think of is that this number on the bottom goes into every single thing on top. So you would rewrite as 2x squared over 2 plus 6x over 2 plus 8 over 2. And that should make sense to you because if you got common denominators, so if you had multiple terms and you got common denominators like this, see how they have multiple terms with the same denominator? You guys know that you can combine them into one with the same denominator. So isn't that just what we had originally? So we're doing the opposite of getting common denominators, we're breaking it apart. Okay, so now that we just simplify each individual term. So if I have 2x squared over 2, we know how to do that, it's just x squared. 6x over 2 is 3x, and 8 over 2 is 4. So x squared plus 3x plus 4. Okay, so same kind of thing on number 2, but now we have 5ab on the bottom, so it's a little bit harder. So I'm going to bring the 5ab into everything on the top. So I'm going to have 5a squared b over 5ab minus 15ab cubed over 5ab plus 10a cubed b to the fourth over 5ab. Okay, so like I said, this is like we're doing the opposite of getting common denominators. We're breaking them apart. Okay, and then we just simplify. So simplify like we did in section 5.1. So 5 and 5 would cancel. If I have two a's on top and one a on the bottom, I'm going to have one a left on top. And then the b and the b cancel as well. So I have a. Okay, this next one I have 15 over 5, so I'm going to be left with 3. The a's cancel, and the b's reduced to b squared. So I get minus 3b squared. And on the next one I get plus 2a squared b cubed. And that's your answer. Okay, easy enough. So if you have a monomial on the bottom, you can just bring that one term into each thing. Okay, so before we talk about like a polynomial divided by a polynomial, let's kind of go back to, like 3rd grade and talk about long division. So a lot of you guys, it's okay, a lot of you guys have forgotten long division because you haven't done it in a while. So when you guys divide, you usually take out your calculator and you divide that way. So how many of you guys have done this within the last year, like the long division? So 3 of you, 4 of you, maybe 5. So not really a lot of you guys. So some of you guys may have forgotten this. So this is why we go over it before we learn about the polynomials. Okay, so the division algorithm says when you divide one number, so we call that number the dividend, by another number, the divisor. So the dividend is on the top. Oops, dividend. The divisor's on the bottom. Keep misspelling. Divisor. Okay, I always remember the dividend is like the bigger word, so it's usually the bigger number. Okay, so I'm going to divide my dividend by my divisor. So that's how I set it up. So 3723 divided by 5. You end up with a quotient and a remainder. Okay, so we're going to have to figure out what the quotient and the remainder are. So if you remember, the first thing you do is you look at the 3, and you say, does 5 go into 3? No. So if it doesn't go into 3, then you look at the 37. So does 5 go into 37? Yeah. How many times does it go in? 7. So you write 7 on the top, And then you take your 7 and your 5 and you multiply them. You get 35. So 35 you write below the 37. Okay. I always say draw the line, change the sign. So we're going to draw the line and we subtract. When we do that, we get 2, and then we drop our next term. So drop 2. It looks like we're repeating the process. So now we say, how many times does 5 go into 22? 4. So now we write that 4 next to the 7. Okay, but we don't take 74 times 5. All we do is we take that 4 times 5 and we write 20 below it, right? So 4 times 5 gives 20. We draw the line, change the sign. So draw the line and subtract. We add straight down, and we get 2. 5 can't go into 2, so we always drop that next term. So drop the term, we get 23. We need another 4. So I do 4 times 5 makes 20. Subtract it out, and when you were in like 2nd grade, 3rd grade, whenever you first learned this, you wrote remainder 3. There was 3 left. So that's how we're going to start it out, with remainders. Now, eventually, when you started talking about fractions, what did you write instead of remainder 3? 3 out of 5. There was 3 left out of your divisor at 5. Okay, so we're going to do that as well.
I always wondered, like, you just add another 0, drop it down, and then I have 30, so I have 400.
Oh, like you did a decimal. Yeah, so you did a decimal point and then added the 0, right?
Yeah.
Yeah. So we're not going to do decimals because we can't have like a decimal polynomial. You know what I'm saying? Like you can't have like, I don't know. I'll get to that. So you'll see with the polynomials. So we're either going to do remainder 3 or we're going to write the fraction form, 3 out of 5. Okay, so let's try with a polynomial. So it says divide x squared minus 6x minus 8 by x minus 4. So I'm going to have x squared minus 6x minus 8, and I'm going to divide by x minus 4. Pretty scary looking, isn't it? Okay. So I'm going to look at this first thing, x. I'm going to say, what do I multiply x by to get close to the x squared? X, right? X times x makes the x squared. So I write x on top. Now think about what we did up here. Once we wrote the 7, we did 7 times 5 makes 35. That's the same thing that we're going to do down here. We're going to say, okay, x times, and we multiply by the whole term now. So x times x minus 4 makes x squared minus 4x. After we wrote our 35, we drew the division line, or the subtraction line, and we changed the sign. So we're going to do that now. So I would say draw the line, change the sign. And I'm changing the sign on both terms. So I'm going to have minus x squared and plus 4x. And then just in case you get like a phone call in the middle of doing these problems, I always circle them so I know that I've already changed them. And it makes checking it later on easier. Okay, then I add straight down. The x squareds go away, and they should go away. That's the whole reason we're doing this. The next one I get negative 6x plus 4x, so I get 2x, negative 2x. So basically we're right here. So we're to where we had the 2. What do we do next above? Right, we dropped that 2. So what we're going to do here is we're going to drop the negative 8. And we repeat the process. That's an x. So I say, what do I multiply x by in order to get negative 2x? Negative 2. So now we write negative 2 on top. So then I take my negative 2 and I multiply by everything in the divisor. So negative 2 times x minus 4. So negative 2 times x minus 4 is negative 2x plus 8. Draw the line, change the sign. So I'm going to have plus 2x minus 8. So when I add straight down, I get negative 16. Okay, now you're done because you can't say what do you multiply x by in order to get negative 16. Okay, so we're going to say that's our remainder. It's negative 16. Okay, so let's look at this division algorithm thing. So the division algorithm says the dividend equals the divisor times the quotient, and then you add on the remainder at the end. So let's check it up here. So on our first one. So our dividend was 37.23. Does that equal the divisor, which was 5, times the quotient? This is called the quotient. So 744. And then plus the remainder, so plus 3. And you can check. If you do 5 times 744, you get 3720. So when you add on the 3, you get 3723. So it works. That's the division algorithm. So basically on these problems, you can always check because you can plug into the division algorithm. So this one, if I did the dividend equals divisor times quotient plus remainder, your dividend was the x squared minus 6x minus 8. Your divisor was x minus 4. Your quotient was x minus 2. And then you tack on the remainder, so plus a negative 16. So let's check. If you multiply these two binomials together, so you could FOIL, you'd have x squared minus 2x minus 4x plus 8, and then you have this minus 16 on the end. This works out to be x squared minus 6x, and then 8 minus 16 is negative 8. Same thing. So you get the same thing in the end. Does that make sense? Okay, so we're going to try some more of these, so don't worry. Okay, so the dividend is, for your blanks, x squared minus 6x minus 8. The divisor was x minus 4. Your quotient was x minus 2, and your remainder was negative 16. Okay, I know these are weird when you first see them, so we're going to do lots of them. Okay, so let's divide x squared, x cubed plus 6x plus 3 by x squared minus 2x plus 2. Okay, so when you have these, notice how you're missing an x squared term in the first one. So you're missing x squared. The nice thing about the last one is that when you looked at your vertical columns, you always had like terms match up. Like x squared's matched up with x's. Numbers matched up with just plain numbers. You see what I mean by that? So you can easily add straight down. So if you're missing a term, the easiest thing to do is add in like 0x squared. So if I'm missing x squared, put in 0x squared. That way your like terms are going to line up. Okay, if you don't, it's fine. It will still work out. But when you're doing your subtraction, like maybe you'd have x cubed, and then you might be combining it with like an x squared term. So you need to like think about the x squared term combining with the x squared. You know what I'm saying? I don't know. I can show you that example if you want. Okay, so let's put in 0x squared. So I get x cubed plus 0x squared plus 6x plus 3. And I'm going to divide it by x squared minus 2x plus 2. So always look at the first term of the divisor, so x squared. Okay, what do I multiply x squared by in order to get x cubed? X. So that's what you put on the top. Then you multiply x by everything in the divisor. So you're going to end up with x cubed minus 2x squared plus 2x. Draw the line, change the signs. So we're subtracting basically, adding the opposite. Add straight down, the x cubes go away. You want them to go away, that worked. The next one I get 2x squared plus 4x, and I'm going to have to drop that 3. You always want the same number of terms here that you had over in your divisor. So that's why we dropped the 3. Okay, repeat the process. So what do I need on the top now? 2. Do you guys see that? Because x squared times 2 is what gives me the 2x squared that's over there. Okay, so I need times 2, or plus 2 on the top. So now I do 2 times everything in the divisor. So 2 x squared is 2x squared. 2 times negative 2x is negative 4x. 2 times 2 is 4. Add straight down. Well, change the signs, right? Draw the line, change the signs. Now add. Now the x squareds go away, which is what we want. Now we have 8x minus 1. That's where we stop. Do you guys see that that's where we stop? Because you can't say what do you multiply by x squared in order to get 8x. Okay, so that's your remainder. Notice on the numerator it was always like x to the first and then a number. It should always go in descending powers. So like if you started out with x cubed on the top, the next thing is going to be something with x squared, then x, then a number. It's always going to go in descending order. So if you're getting x plus 2x, like if you thought that was a 2x, then you did something wrong because it's going to go down. Okay, so write the final answer in p of x equals d of x times q of x plus r of x. Okay, so this is the dividend, divisor, quotient, and then you just tack on the remainder at the end. Okay, the reason there's the of x thing, that's not multiplying by x. It's not saying p times x. It's saying you have some kind of polynomial that has x terms with it. Okay, so your dividend was your original polynomial. So this was the p of x. So you're going to have x cubed plus 6x plus 3 equals your divisor. This was your d of x up there. So that's what you were dividing by. So you're going to have x squared minus 2x plus 2. Your quotient was what you got in the end, x plus 2. And then you just say plus, so there's no parentheses or anything, you're just tacking on 8x minus 1. Okay, so that's how you could check your work to make sure it works out. Okay, so you guys try this one. So notice you are missing some terms. You're missing an x, and you're missing an x on the bottom. So put in 0x for each of those. So you guys go ahead and try this one. Oops. Okay, so I have x to the fourth minus 3x cubed plus 4x squared plus 0x minus 9 over x squared plus 0x minus 2. Okay, so you say, what do you multiply x squared by in order to get x to the fourth? Okay, so you need an x squared. You take that x squared and you multiply by everything in the divisor. So x squared times x squared is x to the fourth. X squared times 0x is 0x cubed. X squared times negative 2 is negative 2x squared. Draw the line, change the signs. So you add straight down, the x to the fourths go away, which is what you want. You get negative 3x cubed plus 6x squared, and you're going to have to drop the 0x in order to have 3 terms like you had over here. Okay, now you say, what do you multiply x squared by in order to get negative 3x cubed? What did I do? Not yet. So we only need 3 things to line up, because we're going to have 3 things that go below it on this next step. You see what I'm saying? So we would have 1, 2, 3. So we're going to have 3 things. We're going to drop the negative 9 eventually, just not right now. Okay, so the next step, so I say, what do I multiply x squared by in order to get negative 3x cubed? So I need negative 3x. So that gives me negative 3x cubed. Negative 3x times 0x is plus 0x squared. Negative 3x times negative 2 is plus 6x. Notice how my degrees went from x squared to x to the first. I'm going to have a number, and then I'll have my remainder. Okay, so draw the line, change the signs, plus, minus, minus. Add straight down. So my 3x cubes cancel. I have 6x squared minus 6x. Now I drop the negative 9, so that way I have 3 terms to line up with the next 3 terms. So I say, what do I multiply x squared by in order to get 6x squared? So you need a 6, so plus 6. Multiply that plus 6 by everything in the divisor, so 6 times x squared is 6x squared. 6 times 0x is plus 0x. 6 times negative 2 is negative 12. Draw the line. Change the signs. You get a remainder of negative 6x plus 3. Okay, so your remainder is... Okay. Now notice these instructions say write your answer in fraction form. So if you went back to what we started with, so that very first example, this would be 744 and 3/5, like we talked about. So you write your remainder over your divisor for your fraction. So if we go back to what we're on now, my answer would be x squared minus 3x plus 6, so that was my quotient, but then you need to add on the remainder over the divisor, so x squared minus 2. That's how you write in fraction form. So in your homework, I'll say different ways. I'll say write it in fraction form, or I'll say write in the form p of x equals d of x times q of x plus r of x. Okay. Did you guys see your mistakes? Did you find them? Are you understanding better? Do you want to do another example or no? One more? Okay, so let's do another one. Okay, so let's say we have x to the 4th minus 3x cubed plus 2x squared minus 5x plus 6. And I want you to divide by x squared minus 1. So what are you going to write over here? X squared. Are you just going to write x squared minus 1? No, you write x squared plus 0x minus 1. That way all of your terms are going to line up. So you'd have like all the x cubes, all the x squareds, all of the x's, and so on. They would all line up. Okay, so go ahead and try that one. Okay. So you say, what do you multiply x squared by in order to get x to the 4th? So you need x squared. You multiply x squared by everything in the divisor. So x squared times x squared is x to the 4th. X squared times 0x is 0x cubed. X squared times negative 1 is negative x squared. Everybody get that far so far? Draw the line, change the signs. Add straight down and you get negative 3x cubed plus 3x squared. Drop the negative 5x. Okay, now you say, what do you multiply x squared by in order to get negative 3x cubed? So you repeat the process, so you need negative 3x. Notice on the top I had x squared, now I have something with x. Okay, multiply that negative 3x by everything in the divisor, so negative 3x times x squared is negative 3x cubed. Negative 3x times 0x is plus 0x squared. Negative 3x times negative 1 is plus 3x. Draw the line. Change the signs. Add straight down. You get 3x squared minus 8x plus 6. You say, what do you multiply x squared by in order to get 3x squared? So you need a plus 3. So I need 3 times 3x squared is 3x, or 3 times x squared is 3x squared. 3 times 0x is 0x. 3 times negative 1 is negative 3. Draw the line, change signs. Add straight down, I get negative 8x plus 9. That's your remainder. So for your final form, if you write it in fraction form, you do plus the remainder divided by the divisor. And that's your answer. Did everybody get it? How many of you guys got it? Only Taylor? Only Gabby? Okay. You would have, I just didn't give you enough time. Okay. So you understand the process now. That's all. Okay. All right, I wanted to show you synthetic division before I set you guys loose for your nice long fall break. So, I know. So synthetic division is a shorthand method of dividing a polynomial by a binomial. So a binomial has two terms, and it has to be in the form x minus a. So for example, like x minus 3, or x plus 5, or x minus 1/2. Those are all in that form. You cannot have like 2x minus 6. Okay, so what we do is we start out with this diagram. So we do like a backwards L, and then a line. So I have an example as we do this. It's a backwards L and a line. Step 2 says write the coefficients of the dividend, including any zeros, on the right of the backwards L. So when I look at my dividend, my coefficients are the numbers in front of the variables. So I'm going to write 2, 7, and 9. And just like before, if I'm missing any terms, I'm going to write zeros in their place. The number 3 says write the zero of the divisor in the backwards L. In other words, you can set the divisor equal to 0 and solve, giving you a. So if I set x plus 2 equal to 0 and I solved, I get x equals -2. So basically, it's the opposite sign of whatever you have here. So if you're dividing by x plus 2, you put -2 in your backwards L. And the way I always remember this is when we did long division, we drew the line and then we subtracted. With synthetic division, we're always adding. So this negative that we have out here is taking care of changing all of the signs. Okay, it's doing that for us. Okay, the next thing, you drop the first coefficient of the dividend. So you always drop the very first coefficient. You get 2. Okay. Now you do like a lattice method. So anytime you're going diagonally, you're multiplying. Anytime you're going up and down, you're adding. So add and then multiply. Okay, so I drop the 2, and I'm going to say -2 times 2. You don't have to draw it and circle that. But -2 times 2 is -4. I put it here. Then I add straight down and I get 3. -2 times 3 is -6. I add straight down and get 3. The last number is your remainder. What's left is your quotient, the 2 and the 3. So think about, if I divided a 2x squared by an x term, don't you guys just have 2x left? So this is 2x plus 3. Okay, so I have 2x plus 3 and then a remainder of 3. Okay, I'd really like to do another one, but I'll let you guys go on your fall break.
I like that one a lot better.
Yeah, but it only works when things are just a binomial and when they have that, like you can't do x squared minus 2, you know, when you have a linear binomial.
I don't like it.